Bailey, you're taking the ACT tomorrow?
Yes.
You can just watch the videos. There are 2 assignments due tomorrow, and I'm going to talk about those today.
Okay. Sounds good.
That's another thing on Schoology. It has section 2.2 homework.
I changed that this morning. Isn't it changed now? I thought I changed that. I saw that too. I thought I changed it. Okay. I hope I did.
Yeah, it has them both due on Thursday.
Yeah. I went through and fixed a bunch of stuff. I also didn't get the, I didn't have a PDF of chapter 2 thing. On, last week. So I went and did a whole bunch of stuff. All right, I'm going to take some roll first. Oh, I'm exhausted. All right, just holler if you're here. All righty, Raina, I saw, Zach, are you here?
Yeah.
Alexis?
Here.
Caleb is here. Sarah?
Here.
Gabe is here. Lily?
Here.
Tucker is here. Grayson's here. Karina?
Here.
Gibbs?
Yeah.
Ella?
Here.
William?
Here.
Bailey?
Here.
Sophia?
Here.
Jaden?
Here.
Morgan?
Here.
Jordan?
Here.
Audrey?
Here.
Hope? 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 3 times. All right, let me close out of this. All righty. So we're going to talk about, because there are 2 things due tomorrow, and one of them is that GeoGebra activity. So a lot of you, I got a lot of emails about, or texts about frustrations about getting that. So we're going to take care of everybody today. So if you have not had it, you will need to get it on your computer. It's due tomorrow morning at 8 o'clock, plus another assignment is due tomorrow at 8 o'clock. So I'm going to show you my screen. And then I'm going to show it to everybody else. Bisters, do you see this screen?
Yes.
Okay, this place is called geogebra.org. Okay, the one you want to download isn't the one that says you want to download GeoGebra Classic 5. 6 will be bad. I'm going to show you in a second. Okay. You do not want 6. You want 5. 6 will be bad for you. Okay, and I'm going to tell you some other stuff. William, you've already done this, correct?
Yep.
Okay, so this is what you want to download. Since it's not an Apple product, Apple will give you a warning. So what you want to do is double click or right click on it with 2 fingers. Does everybody understand what I mean by that? And then you should be able to go to the very top and open it, and it'll give you the same warning, but then they'll say, open this application anyway. Do you all understand and are you successful? Yep. And then, okay, did you right click on it? And now it should say, it'll give you the same warning, but you should be able to get like a drop down thing where it opens up and says, yeah, take it anyway. I need to know if that did not happen by anybody, either out in the abyss or in the classroom.
I'm having trouble with it right now.
Who's that?
Sarah.
Okay, so tell me what kind of trouble you're having.
Okay, so I just downloaded GeoGebra Classic 5.
Yep,
And
and
then-
it comes down as a zip file, correct?
Yeah.
Then you got to drag it onto your desktop.
Okay.
So you'll get a zip file downloaded, drag it onto your desktop, and then you should be able to open it up and put it in your applications folder. Yeah. Did it open up my thing?
Yeah, you just have to like break it into the app.
Okay, that's fine. No, you don't have to do it. I didn't know you could even solve it that way.
Yeah, I just downloaded it on the Mac Store.
Yeah, I know it's on the Classic 5 isn't on the App Store.
Yeah.
And yeah, but I didn't know that was a solution that you could drag that my thing into that application. I didn't know that. So, because I know it won't let me open it. And it worked then, huh?
Yeah.
Yeah, if you got it to work and you filled out the thing, you're fine. I just want to make sure everybody's able to do it, okay?
I still can't open it though.
Okay, did you use 2 fingers to click on it?
Okay, so I dragged the file onto my desktop.
Yeah?
And then I click it with 2 fingers.
Yeah, whatever a right click is.
Okay,
Hello?
what should I,
Hello,
like, what
Hope.
option should I choose?
What are your choices?
Okay, well, I just see like open or open with. So do I just click open?
Yeah, I suppose, yeah. Hope, we're downloading GeoGebra. Were you able to do that?
No.
Okay, can you go to this website right here that can you see my screen?
Yeah.
Yeah, go to geogebra.org. And then you want to download GeoGebra Classic 5. And it'll give you a warning, but if you right click on it, which means you use 2 fingers, you'll be able to open it. Sarah, were you able to open it?
No.
Yeah, mine isn't either. Mine won't work.
Who?
Gibbs.
Were you able to get a zip file?
I don't know.
What do you mean you don't know?
I don't know what a zip file is.
You don't know what a zip file is. Did it download anything? Here's what else we can do. If you're having trouble, if you have a friend in class that did not have any trouble, then you want to talk to them and figure out how they did it. Okay? Because I'm going to continue on with the notes. I got notes, all the notes for the entire week for you. And when these,
Ruger, do you want us to sign in with Google on the GeoBra?
you don't have to sign in at all.
Okay, just exit out.
Yep,
Okay.
it's not a requirement. That's a great question. Anybody else have any questions before I start notes? Well, from sound of silence, that must mean everything's okey dokey. All right, I'm gonna turn this off. Turn this on. And I can't remember where we ended off. All right, you guys have any notes at all in here? You have the 2-1 notes? Okay. Here are the 2-2 notes. Here are the 2-3 notes. Yeah, we're having the quiz on Thursday, so I didn't change that yet. I have it in a meeting this morning. All righty, so I've been busy, and thank you for all the emails and everything like that. I got everything caught up. The homework should have all Chapter 2 PDFs in it. Their due dates are Thursday. The quiz got moved to Thursday. There is an assignment, 2 assignments due tomorrow. One is that activity, and the other one is, it's 2 pages, 5 questions. We're gonna go through, it'll be on the information that I go today. I think there's one that is A, B, C, D, something like that. E, F, maybe, okay? So I'm trying to remember where I know what I was gonna say. Bisters. You guys all have the 2-1 notes? Karina, you do?
Yeah.
All right. Karina, can I ask you another question since you're nodding?
Sure.
Can you tell me where I ended up?
We did number 2 and example 4.
It was example 4 look like this. Well, I haven't, you guys have no idea. I haven't shared my screen, have I? Like this kind of? Do we get 14 as our answer?
Yeah.
Okay, super. So I may have not had all this information here. Okay, so I'm going to talk about this information. First of all, right here, right here, right here, and right here are all saying this is the derivative of this function. So what I mean by derivative is that it is asking you to find the slope of the tangent line when x is 2 on this function. Find the slope of the tangent line when x is 2 on this function. Find the slope of the tangent line on this function at x equals 2. Find the slope of the tangent on this function at x equals 2. The most common ways are this way, to say, hey, find the slope of the tangent line, this way, and this way, right here, y prime at x equals 2. You'll see me do that all the time. So this is a shortcut of writing the derivative or writing slope of the tangent line. This thing indicates this value, the derivative, at 2, the slope of the tangent line is 14. The instantaneous rate, the rate at 2 is 14. Everybody with me on that? Bisters, are we doing okay with that? All right. I'm going to skip 1 and I'm going to skip this and I'm coming back to it. All right. I am going to we'll come back to that. You see this one right here on the back side? Does everybody see it? I'm going to cross it out. Okay. And I'm going to write this. Okay, WT, and I need a new pen because this pen is dying. A function that describes the distance walked by Rosie, my dog, and I, where WT is feet and T equals minutes. Okay. So I'm going to draw you a graph. This is the graph of the function. Okay. Okay, Ella? Ella,
Okay.
I got a question for you. What's W1? Ella,
Is it 11?
how'd you get 11?
I plugged it into the function at the top.
And what did you do with the 1? What was the first thing?
Oh wait, is it 9?
Well, it's either 9 or 11. Which one do you think it is?
Nine.
No, it's 9. Perfect. 9, 1.
Nine minutes?
It says this. WT, this is a function that describes the distance walked by Rosie, my dog, and I, where WT equals feet.
Oh, it's feet.
Okay, so it's 9 feet. Perfect. So right here is where 1 is, correct? Right here is 9. Okay. So after 1 minute, I've walked 9 feet. Tucker, what does this mean in my graph? So what happened here? Here we're walking, right? Because Rosie and I are walking. After 1 minute, we're here, correct? And then after so many minutes, we're here, correct? Oh, it turned around. It's a turning around point, correct? And I headed back home. So I'm home after 10 minutes. Would you say that? You know why that happened? My wife wasn't with us. And Rosie doesn't like that. She wants us to go as a family. And so it was all really cool. And then we got so far away, and then boom, we had to come back. Right. So let me pick on somebody else. Jordan Smith. What's this stand for?
Wouldn't that be the tangent line at 1?
The what of the tangent line?
The derivative, so the slope.
Oh, perfect. The slope of the tangent line at 1, which I can kind of draw right here, correct?
Yes.
Okay. Will you tell me how to figure that out? Jordan, how to set it up?
So you would have your function first, which would be negative t squared plus 10t.
Okay, slow down for me. Okay.
Then you would subtract it from 9.
Right, I'm
So-
gonna write -9, correct?
Correct.
I'm taking the limit here first, right? It's
Yeah.
approaches what?
As it approaches 1.
Perfect. Very good. I'm very impressed. Over what?
X minus 1.
T minus 1.
T, sorry.
Yeah. But don't worry, I make that mistake all the time. So it doesn't mean those are good mistakes, but I make that mistake. Okay. So we can't substitute, can we, Jordan?
No, you cannot.
So I've got a factor, right?
Yeah.
Okay, now what I do, because negatives bother me, is I factor out a negative. It's really a -1. And I get t squared minus 10t plus 9. Would you agree?
Yes.
Okay, so now I know for this to be successful, I got to have a t minus 1 in there for sure, right?
Yeah.
What's this other one have to be?
Um,
What two numbers can I multiply together that give me 9, and when I add them, give me a negative 10?
oh my gosh. -9.
Minus 9, correct?
Yeah.
Okay. Do I get to use my red pen here? Of course I do, right?
Yeah.
Bam! So now my limit as t approaches 1, I can put in this, correct?
Yes.
Okay. And what will I get as an answer when I plug 1 into that?
You will get a +8.
I'll get 8. So this is 8 right here. So the slope of my tangent line is 8. Okay? Jordan, you did wonderful, by the way. Can I keep asking you questions, or you want me to let you go?
You can fire away.
Okay. What's my unit? 8 what?
8 feet per minute.
8 feet per minute. So it means after 1 minute, I have gone 9 feet, and at that moment, I'm walking 8 feet per minute, correct?
Yes.
Okay. You did wonderful. I'm very, very pleased. Okay. Jaden,
Yeah.
you know how somebody, I think it was Tucker that said, maybe, I'm pretty sure it was, that this is a turning around point. Didn't you say that, Tucker? Right? So there's a spot here, correct? Right, would you agree with that? That there's a tangent line that's horizontal? Jaden?
Yeah.
Okay. How fast am I walking at that moment?
0 feet a minute.
Yeah, I'm stopped, aren't I? Would you agree with that, Jaden?
Yeah.
I stop momentarily to turn around and head back, right?
Yeah.
Okay, very, very good. All righty. So let's look at this next example, and then we're going to back up a little bit. It says the position of a ball that is dropped from a height of 400 feet can be modeled by a function defined as s of t equals a negative 16t squared plus 400. So that means if I put like 1 in here, that ball would be 384 feet above the ground. Everybody got that? Okay. And then it says find a function that can describe the instantaneous rate at any time t. Notice in this case, I don't have any numbers. It's not asking for a numerical derivative. It's asking for a derivative formula. A formula that its purpose is to compute the slope of any tangent line on this graph. Sometimes we call this the general derivative. It will always be in terms of our input value. So like in this case, it'd be in terms of t. Can I go on? Is everybody okay with that? All right. So let's back up. So the very first question on one of tomorrow's assignments is define derivative. What's the definition of derivative? A derivative is the slope of a tangent line or the instantaneous rate. Okay. Then it asks to give the two limit definitions for a derivative. One of them is this. That's the one Jordan just used, right, Jordan?
Yeah.
Okay. Here's the other one. You could also give this, or the limit as h goes to 0 of f of x plus h minus f of x over h. This gives you the general derivative. Its purpose is if I know x, I can find the slope of the tangent line. I can plug it in. The idea behind this is delta x or h is the distance between 2 points as one point moves closer to the other. So, like this, if I were to draw this graph, here's my tangent line right here. I'm moving this point really, really close. And if I come down to the x-axis here, this right here is delta x or h. This distance right here. Is that making sense? And as that approaches 0, means I'm moving this point even closer. And so that distance is getting smaller. So I'm going to show you how it works on this problem. So I'm going to use h to begin with, and I don't care which one you either use delta x or h. So I'm going to use h in this case, as h moves to 0. So it's always the case h is going to 0. And the first thing I'm going to do is I'm going to write the function, but rather than input x, I'm going to input x plus h. And what am I going to do with that input? Well, it tells me to cube it and then add 1. So I just replace wherever I see an x, x plus h. Minus, now I always put parentheses if I have more than one term, x cubed plus 1 over h. So this is f of x plus h. This is f of x. And what's going to happen once I do all this work, this x cubed and this 1 will be gone, and I will be left with terms that have an h in either one of them, maybe more than one h. And I'm going to factor out an h. So I'm going to do a little bit of algebra now. And I'm going to expand this. And you guys probably forgot how to do that, but I haven't, so I'll do that for you. So I'm going to show my work right here and then come up with my new limit. So I'm going to have x cubed plus 3x squared h plus 3xh squared plus h cubed. So what am I doing? I'm taking x plus h times x plus h times x plus h. And if you did that, that's what you would get. I'm really using Pascal's triangle, which I think Mr. Karsh taught you guys last year, right? Notice these are my leading coefficients. You remember that? Maybe not.
Yeah, kind of.
Okay, plus 1. Okay, so this right here is this function right here. Now I'm going to subtract the other function by distributing this minus sign. And now notice this term and this term are gone. This term is gone with that term. And I'm left with 1, 2, 3 terms. They all have H in them. So far I'm successful. And I'm going to factor out I'm going to factor out an H. And I get 3x squared plus 3xh plus h squared all over h. And then these can be simplified. So now I no longer have division by 0 because I was able to get rid of that h. So now what I'm going to do is I'm going to take the limit as h goes to 0, and I'm going to rewrite these 3 terms. 3x squared plus 3xh plus h squared. Now remember, since I'm looking for a general derivative, I want an answer that's in terms of x. In Caleb, I'm going to replace h with the number 0 in this term and in this term. But I'm not in this term because there's no h, correct? What will I be left with? 3x squared. And that thing is called my derivative. That's my general formula of a derivative, and I'm going to call it f prime of x. So on this graph, if I plugged in if x equals 1, the slope of my tangent line is 3. If x equals 0, the slope of my tangent line is 0. If x equals 2, the slope of my tangent line is 12. It got really steep all of a sudden, didn't it? If x equals 3, the slope of my tangent line is 27. This computes the y's. This computes the slope of the tangent lines. We call it the derivative of f prime. It means this is the rate at which my function is growing. It's growing at a rate of 3. Now it's growing at a rate of 12. Now it's growing at a rate of 27. It's really growing fast. Morgan Schreifels, any questions so far? Morgan. Morgan. Hello, Morgan.
I don't have any questions.
Oh, good. You don't have any questions. Okay. Super. Because I'm going to ask you a question. And right here, you can see there's your second definition of a derivative, right? This is one if we know x or we know the point. Okay. We've done this problem, haven't we, or no? Okay, we'll come back to that. But Morgan's going to help us with this one. So over here, we're going to get a general derivative. All right. Morgan, are you going to use the delta symbol or h?
The delta symbol.
The what?
The delta symbol.
Okay, so since our input is t, we're going to say the limit as delta t goes to 0. Okay?
Okay.
Okay. And what's going to be on the bottom?
Wouldn't it just be delta t?
Pardon?
Delta t?
Yeah, perfect, delta t. Okay. So now here's my function, and I'm going to have a negative 16 parentheses, something in it squared plus 400. 400, not 40, 400. What am I going to put in there, Morgan?
I'm not sure.
Not sure?
No.
Over here on this example, I had X plus H because X was my input value and we chose to use H. So here, my input value is T and you chose delta T.
Would it just be delta or x plus delta t?
Yeah, it's going to be T plus delta T. Perfect. Okay. Minus in parentheses what? And if we look at this one back here, in parentheses, I believe was just the function, x cubed plus 1. So our function is what here?
Is it t plus the delta t?
It's this right here. It's a negative 16t squared plus 400. So here's my function with t plus delta t in it. Here's my function with just t in it. William, are you there?
Yes, I am.
Okay, I'm going to have a negative 16 parentheses. Can you expand that for me?
That's going to be t squared plus 2t delta t plus delta t squared.
Okay, plus 400. Lily, can you distribute this minus sign for me?
So positive 16t to the second minus 400.
Perfect. Perfect, perfect, perfect. Over delta t. Delta t goes to 0. All righty. Sophia, you want to distribute this negative 16 for me?
It would be negative 16t squared minus 32t delta t minus 16 delta t squared.
Plus 400 plus 16t squared minus 400. And there is a little bit of elimination here, 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 here. Okay. And I have a delta t in this term and a delta t in this term, and I only have two terms. So I can factor out a delta t, and I'm left with a negative 32t minus 16 delta t over delta t. And I can simplify those. Back to Morgan. I got the limit as delta t goes to 0, and I get a negative 32t minus 16 delta t. Correct, Morgan?
Correct.
Now, what's my answer? What's the limit?
Negative 32t.
Perfect, negative 32t. Now, notice S of t is this, correct? We would say S prime of t is equal to a negative 32t. S of 1, I believe I said, was 384 feet, which means at 400 feet, a ball is dropped. 1 second later, it's at 384 feet. Alexis, if I plug a 1 in there, what do I get?
I'll pass.
Well, plug 1 into here. What's a negative 32 times 1?
-32.
Perfect. Okay. So do you know my unit, or would you like to pass on my unit? Oh, I should tell you this. My time is seconds because I forgot to put that in. I do tell you that the Y value is 400, but my output is 400, my input is seconds. Sorry. So at 1 second, I'm at 384 feet. If I plug 1 into here, I have a negative 32. That's the slope of my tangent line, but it has a unit. What unit does it have?
Is it feet per second?
What per second?
Feet per second?
Perfect, feet per second. Okay. Grayson, why is it negative? Because it's going down. In other words, this is a velocity. It's a velocity. And Gabe, it's going down if it's negative. If it was positive, it would be going up. It'd be going the opposite direction. Now, at 1 second, what is its speed? I didn't hear you. Yeah, speed does not have 2 P's in it, for one thing. Speed is equal to the absolute value of velocity. So its speed is 32 feet per second. Velocity actually tells you 2 things. It tells you speed and it tells you direction. So if you go back to my walk with Rosie, right here, I could have a tangent line. This tangent line over here was 8 feet per minute. This tangent line right here could be a negative 8 feet per minute. We're going the same speed. Here I'm walking away from my house. Here I'm walking back to my house. Does that make sense? Karina, does that make sense?
Yep.
Bailey, does that make sense?
Yeah.
Okay. All right. So let's look at, I know I'm jumping around, but now we will look at this. So you have 2 choices. You can use this limit definition. Or you can choose this one. You can always use this one for this one, but this one cannot always be used. So I am going to ask Bailey Rader, which one should I choose?
The second one,
Why?
because you're given a point.
I'm given a point. Okay, Audrey, she chose this one for you to do. So X is going to approach what, Audrey?
Is it gonna approach 2?
2, perfect. And on the bottom, what do I have?
Would
would it, oh goodness. Would it just be? I'm not sure, I'm sorry.
So right here's what you said C was 2 right here, correct?
Would it just be x minus 2?
Perfect. That's exactly what it is. Okay. So up here I have a minus, right?
Yeah.
Okay, what will I have in the front part here?
The front part would, oh, I have to do math, don't I?
Not for the front part.
Oh. It's just-
Right here it says f of x. Remember y and f of x are the same, correct?
So would it just 11? I'm sorry.
We will have a number there, but eventually, but all I'm going to do is put in this function. So I'm going to put in x
Oh.
squared plus 3x plus 1.
I thought that was the last one.
Okay, and then minus 11.
Okay.
And you got 11 how?
From the point that we were given.
Great, the function.
Yeah.
Oh, yeah. Well, yeah, if I put 2 in here, I would have gotten 11, but I already told you it was 11. Okay, yeah. So you want this f of x. F of c is always this y value.
Mhm.
Okay. All right, super. Let's simplify this. Here's x minus 2. This is x squared plus 3x what?
Minus 10.
Minus 10. Perfect. And now let's factor that. My guess is we're going to need an x minus 2 up there. What's this going to be? X what?
X plus 5.
Perfect. Bam, those are gone, correct?
Mhm.
So you're going to rewrite your limit as the limit as x approaches 2, but you're going to use x plus 5, correct?
Mhm. Yep.
And you get what?
7.
So, and that's the slope of my tangent. Very good. Sophia, did I ever show you y with that little t in the bottom right-hand corner?
Maybe, but I don't remember it.
Okay, what this is going to be the equation of the tangent line that passes through 211 that has a slope of 7. To come up with the equation of a tangent line, you need just 2 things, slope and a point. And I'm going to use slope, point slope form. So there's 7, x minus my x value, which is 2, plus my y value, which is 11. Now that's, you will be asked to find the equation of the tangent line in your homework and on a quiz and on the test and on the AP exam. I don't go any further than this. One, because it's right. And secondly, time's an issue. And sometimes I see people do this. And then they say that's the equation of my tangent line. And AP will mark that wrong. And you made an arithmetic mistake. Okay. So that's why I stop here. And that's what I would encourage you to do. Is that all the notes on that form? I believe so, isn't it? All right. So I'm going to do 2-2. Okay. And we're going to start with Gabe. So you're also on the sheet that I gave you, you're going to have problems like to do. So they want you on this, on the notes, they want you to find the derivative formulas. Okay. So again, you have two choices. You have choice number one, the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Or you have two, the limit as x approaches c of f of x minus f of c over x minus c. Okay, you have either of those two choices. You have to find the derivative formula. Gabe, which one are you going to choose? Number one or number two? Number one. Okay, now you have a choice. You want to use delta x or h? H. So you're going to write the limit as what? H goes to what? 0. And down here, you're going to have h, correct? Okay. I think this one's the hardest one. That's why I chose you. Okay. This is saying whatever I put in here, I'm going to get the number 7, correct? So f of x plus delta x, what should I write here? 7, because it doesn't matter what I put in there. Minus what? 7. What is 7 minus 7? Bingo, you're done. So the derivative of any constant is 0, always. You did very well. Well, think about it. The graph of this is a horizontal line, correct? Which has a slope of 0. And when you have a line, the tangent line coincides with that line, correct? So it's going to have the same slope. Make sense? Caleb, you're next. Delta x or h? So you're going to say the limit as h goes to 0. Down here, you're going to have h, right? You're okay with that? What are you going to have here? Remember, you're doing this, right? This is your input. So if I input that, what would my output be? Okay, if I put a 1 in here, I get a 1. If I put a 2 in here, I get a 2. If I put a 3 in here, I get a 3. If I put an x plus h in there, I should get what out? Perfect, x plus h. Minus what? Whatever f of x is, correct? X. So these two are gone, correct? Right? I can simplify h over h, can't I? What is that? 1. So now I have the limit as h approaches 0 of 1. What does that give me? One. Right? Because h isn't going to change the number 1, right? Because there's nothing to put h into, so it's going to be whatever that constant is. Okay? Grayson, delta x or h? H. So I got the limit as h goes to 0. H is on the bottom. What's on top? Yeah, Grayson. You're doing this whole thing, Grayson. Doesn't this mean whatever you input here, square it? Right? And I'm inputting, I think it's going to be x plus h, that quantity squared, minus x squared. Because if I put anything I put in here, I'm going to square it, correct? So if I put in, this pen is driving me nuts. If I put in an x plus h, that means I got to square it, right? Right? Minus what? X squared, okay? So expand x plus h squared for me. Minus x squared, correct? All over h, correct? Okay. These are gone, right? So now what's my next step? Take an h out of there. I have 2x plus h over h. Would you agree? So now my limit is going to become the limit as h goes to 0. These are gone, right? 2x plus h. And what do I get? 2x. I'm going to back up for a second, Tucker, okay? Because you're going to be next, okay? So right here in purple, I'm going to write that the derivative here was 0, correct? Here I'm going to write that the derivative was 1, correct? Here I'm going to write that the derivative is 2x. All right, you ready? Limit of what? Well, you're going to use delta x. You're going to be old school. So delta x will be on the bottom. What will be on top? Cubed minus x cubed. Perfect. Do you know how to expand that? It's x cubed plus
3x squared delta x plus 3x delta x squared plus delta x cubed.
Oh, awesome. Minus x cubed, correct?
Yep.
All over delta x, right? So I'm going to get rid of these. The x cubes are gone, right? And there's a delta x in each one of these. So I'm going to factor out a delta x. And I get 3x squared plus 3x delta x plus delta x squared. Do you agree with that? Those are gone. So this is going to be the limit as delta x goes to 0 of what? 3x squared plus 3x delta x plus delta x squared. What do I have left? 3x squared. So the derivative here Raina, do you see any pattern? Yes. You know what I'm going to do here, Raina? Can I write a 1 right here? Is x the same as x to the first? And right here. And right here, could I say f of x is 7x to the 0 power, because x to the 0 power is 1 and 7 times 1 is 1. Is that helpful with seeing a pattern? let me ask you this. This is a lot of work, isn't it, Raina? What if I gave you this? Can you see that? What do you think? Oops, let me say this. Sorry, that's what I meant to say, Raina. What do you think the derivative formula would be? 4x to the third. You did that pretty fast, and it's correct. You want to tell the people what you're doing? What do you mean add 1?
The number on each one, like the first one is 0, and then it's 1, and then it's 2x, and you add 1, and it's 3x.
Oh, okay. I see. Well, what if I did this? Could you take the derivative now? Hmm? Ninety-ninth power. Very good. That's exactly what it is. So I'm going to ask you another question, Raina. Okay. F of x equals 3x to the third. What's the derivative formula? You've been perfect so far. And I know you love, I could just tell by your eyes, you're a perfectionist, right? Do you know what the exponent is? You know, like here it's 3, right? I didn't hear what you said. Second power, correct. It is x to the second. What? The coefficient is 9x to the second, correct. Excuse me, the coefficient is 9. Your derivative is 9x to the second. Huh. Very good. William, do you see that pattern?
I do.
So you see this one?
Let me see. So that's x to the -1. So it's negative x to the, and then you subtract 1. So was it to the -2nd?
Correct.
So it's -1 over x squared.
Correct. So what do you do? How would you generalize what Raina saw, William?
Okay, so you multiply the current coefficient by the exponent, and you make that the new coefficient, and then you subtract 1 from the old exponent.
So like what you did, let me just reiterate what you said. The exponent here was a -1, right?
Yep.
So you get it in exponent form, I call it.
Mm-hmm.
Once you identify that, you take this exponent times the coefficient you have out front,
Mm-hmm.
and then subtract 1 from your current to get your new one, correct?
Yep.
All righty. What about, we haven't called on yet.
Mr. Kruger,
Yeah.
before we move on, can you just go over those last two again?
Which two? This one?
The one that Raina and William just did.
Oh, yeah. Okay. So let's take a look at this. Let's look at this one right here. The exponent's 3, the coefficient is 3. To figure out the derivative, I'm going to take this exponent times this coefficient, that is going to be my new coefficient. And then I'm going to subtract 1 from this exponent to get my new exponent. So I'll have a new coefficient and a new exponent. If I take a look at this one, my coefficient was 1. So 4 times 1 is my new coefficient, which is 4. And then I'd simply subtract 1 to get 3. So what William identified is I got to write this to know what its exponent is. It's a -1. So I'm going to take a -1 times 1. That gives me a -1, which is what I have right here. And subtract 1 from that -1, which gives me a -2. And then I can write it back as a fraction. Does that kind of make it clearer or not?
That makes sense.
So Bailey, how you feeling about that?
Good.
Because you know, number 6, can you write x with an exponent for number 6 for me? X to what power?
Is it just the first power? Oh no, it's squared.
Yeah.
Squared.
Yeah. So what's the exponent?
2.
What?
2.
No, when you have radicals, you have fractions as exponents. So it's not 2. Otherwise it'd be x squared, and this is square root of x.
Is it 1/2?
Yeah, 1/2. Perfect. Perfect. Absolutely perfect. What's the coefficient that's in front of here, Bailey?
1.
1. Perfect. So here's the derivative. What's a half times 1?
1/2.
Perfect. So that's my new coefficient. X. Now I got to subtract 1. I always subtract 1. Okay, never anything else, just 1. What's a half minus 1?
-1/2.
-1/2. Perfect. So now that's the same as 1/2 x to the 1/2. Would you agree?
Yeah.
Which is the same as this. Would you agree with this? Bailey.
Yeah.
Okay, that making sense, Bailey?
Yep.
Gibbs, you out there?
Oh, yes, I sure am.
God, it's nice hearing your voice, Gibbs. Everybody smiles when I call on you in here. I don't know why that is. What power does this one have?
What power?
Yeah, what exponent? Right? Aren't they? Don't you call them powers? I call them powers.
Is it a -1/2?
Yeah, -1/2, because it's in the opposite place, correct?
Mm-hmm.
What's the coefficient out front here?
1.
1. So you're going to take a -1/2 times 1, correct?
Mhm. Yep.
What's that?
-1/2.
-1/2, of course. X to what power? What's the exponent?
-3/2.
Yeah, -3/2. Very good. And so this is the same as a -1/2 times x to the 3/2, correct?
Mm-hmm.
Okay. I could write it like this too, Gibbs. 2 square root, because that's what the half means, x cubed, right?
Yeah.
You okay with that?
Yep.
Yep. Alrighty. Awesome. 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 Hope. You see how I made a mistake here? I forgot the letter F.
Yeah.
Can you write this? So x has an exponent, Hope. X to what power?
Pass.
There's no radical.
Mhm.
So it's going to be a 2, but it's below it's in the denominator. So it's going to be what kind of 2?
I'm not sure.
When exponents are in the denominator, when I get them out of the denominator, they have what sign in front of them?
Negative.
Yeah, so it's going to be a -2. Very good. What's the coefficient here?
1.
1. Perfect. So the derivative, what's -2 times 1? Oh,
-2.
perfect. X to what power? You got to subtract 1 from a -2. We got to go backwards 1. What do we get?
-3.
Yes, -3. So our answer could be written as a -2 over x cubed. Okay? Alrighty, we are going to end the day. We're in really good shape. We'll finish these notes out tomorrow. Remember, I have 2 things due by 8 a.m. tomorrow morning. If you got questions, feel free to contact me. I will probably be returning any texts or questions probably 7 or later tonight because I got something going on immediately after school. All righty, everybody take care and we will see you tomorrow.
Mr. Kruger,
Yes.
can you put today's recording on Schoology?
Yeah, so what it's going to do, it's going to download onto my computer and then it will be on today, but it's probably be done around 7-ish tonight, okay?
Okay.
Yeah, so what I gotta do, one of them's downloaded and then I gotta put them on YouTube and they take a little bit to process, but I will do that as soon as I'm back from my event, okay?
Okay.
All right,
Would
thanks.
it also be possible for you to put like scanned copies of the notes
Yep, they're
like
on.
that you physically did?
Yep, they're on already.
Like the ones that you, not the like blank ones, but the ones that you have written on.
Yeah, I think they're on, yep,
And the ones from today, you're gonna have those on too?
yep.
Okay, thank you.